In this video, I'll be explaining about the concepts based on waveforms of signals and systems. So without any further ado, let's get started. This question was asked in the year 1994, and the question is that there are two columns, the left hand side of the column and the right hand side of the column. There are 4 waveforms on the left hand side and 7 mathematical description on the right hand side, and we have to match the waveforms with their mathematical description, and we have a few options. Now basically there are two methods for solving question based on these types. First is writing the mathematical description for the waveform, or we can also write the waveforms for the mathematical description provided. Here you can see there are 4 waveforms, so it will be easier for us to write the mathematical descriptions of the 4 waveform instead of writing waveforms of 7 descriptions. But at this point of time, you should be able to do both. That means you should be able to write waveforms by seeing the equations and also equations by seeing the waveforms. Now coming to A, that is quite simple because it is just a ramp function. Now ramp is basically given as r of t, but here r of t is not in our option. Every option is based on unit step signal. Now by seeing the graph, we can say that the waveform is basically a straight line, and every straight line can be written in the form of y is equals to mx plus c, where m is the slope of the line and c is the intercept of y-axis. This is very important because some people get confused in intercepts of y-axis and intercept of x-axis. Now checking from the option, we can say that the intercept is basically 0 because the line is meeting y-axis at 0, and slope is also given by change in y upon change in x, where in this case both are 1. That means our slope is 1. Then according to this equation, we can write y is equals to x, or basically t. But please make note that if y equals t, then that waveform should look something like this. It will also pass through the negative axis, but here in the question there is no negative axis, and in order to make this only applicable for negative axis, we have to multiply it with u of t. That means our y should be t into u of t. That would make the graph as in A. Now this mathematical expression goes for waveform A. From the right hand side table, we can see that this expression is present with R. That means our A will be matched with R. And from the options, we can eliminate both C and D because here A is matched with T and A is matched with P. Now on solving further, we will take our waveform 2, and here this waveform is similar to our waveform A, which is t into u of t, but only difference is it is right shifted by one term. That means A here was t into u of t. Now shift this expression on right side. That means we have to replace t by t minus 1. That is, option B should give us t minus 1 times u of t minus 1. And by seeing the right hand side of the table, we can see that this is present in u. That means B should be matched with u. And by checking the options, we can also rule out option A because B is matched with S. Hence our right answer should be B. If you are finding difficulty in shifting a waveform to the left or right because sometimes it becomes crazy, you can also try writing the waveform B by y is equals to mx method plus c, and here m will be change in y upon change in x. That should be 1 minus 0 divided by 2 minus 1. Here the slope is again 1. And for finding y-intercept C, we have to use a little trick here. First what we will do is we will write y is equals to x plus c because slope is 1. And on putting the value of x as 1, y should be 0. On substituting this in the main equation, 0 equals 1 plus c and c becomes minus 1. That means our b will be x minus 1. On drawing the equation x minus 1, our line will pass like this. It is 1 here and it will be 2 here. And it will also go on the negative side. But in the question, it was not on the negative side. So we have to multiply our unit signal here. On multiplying these two waveforms, we will get our answer as, we will get our output signal like this. But it will also have this part. Why? Because this signal u of t will be multiplied only for the positive term, but here it will also be multiplied for the values from 0 to 1, which was not in the question. Here you can see it is not present here. That means we have to shift this u of t a little bit further, that is at t minus 1, and in that case this part will be removed. That should bring us our answer for the B, and the waveform is x minus 1 into u of t minus 1. If you find this video useful, please click the like button. Don't forget to share this video with your friends and also subscribe this channel to get more concepts like this one.